You've seen this image 1,000 times. Familiar, ordinary, ringless. But what if I told you that everything you're looking at, this clean, bare planet, is a lie? Not a metaphor. Not a theory buried in some fringe journal. A growing body of geological evidence now suggests that Earth once wore rings. Massive, rocky, glowing arcs of debris stretching across the sky. And here's the part that should genuinely unsettle you. Those rings didn't just make Earth more beautiful. They may have ended almost everything alive on it. It started with a map, and a question nobody could answer. Geologists have spent decades cataloging ancient impact craters, the scars left behind when asteroids collide with Earth. And for a long time, these craters appeared scattered randomly across the planet's surface. Random distribution made sense. Space doesn't aim. But then researchers noticed something strange about the craters dating back to around 466 million years ago. They weren't random at all. They were clustered. Almost every single one of them lined up along Earth's equator. Now, here's why that matters. When an asteroid drifts in from deep space and hits a planet, the impact site is essentially a cosmic coin flip. North Pole, Southern Hemisphere, somewhere in the middle. The odds don't favor any particular latitude. So for a significant number of ancient craters to all cluster near the equator, the statistical probability of that happening by pure chance is vanishingly small. There had to be a reason. And when researchers ran the numbers, only one explanation fit. Those asteroids didn't come from space. They came from above, from something orbiting Earth itself, from rings. To understand how a rocky planet like Earth ends up with rings, you need to understand one of the most elegant and brutal concepts in orbital mechanics, the Roche limit. Every large object in space has one. It's an invisible boundary, a gravitational tripwire. Cross inside it, and the tidal forces generated by the planet's gravity become stronger than the internal forces holding the intruding object together. In plain language, get too close and the planet tears you apart. Scientists now believe that around 466 million years ago, a large asteroid, possibly a fragment of a larger collision that had already occurred in the asteroid belt, drifted too close to Earth. It crossed the Roche limit, and Earth's gravity did what gravity does. It pulled the rock apart, not explosively, but slowly, piece by piece, fragment by fragment, until what had once been a single body became a spreading field of rubble orbiting the planet. A ring. But here's where Earth's rings would have been fundamentally different from Saturn's. Saturn's rings are icy. They reflect sunlight brilliantly. That's why they gleam so visibly from a billion miles away. Earth's rings would have been rocky, dusty, dark in places and glowing in others. Not the pristine white arcs of a gas giant, but something rawer, something more dramatic. From the surface of Earth, the experience of looking up would have been unlike anything humans have ever witnessed. Near the equator, the rings would have risen almost directly overhead, an enormous glowing band, like a permanent aurora borealis made of stone, stretching horizon to horizon. At night, the ring would catch sunlight and scatter it downward, illuminating the landscape brighter than a full moon. From higher latitudes, the perspective would shift. The rings would appear at an angle, like a cosmic ridge cutting across the sky. And in the polar regions, the rings would vanish entirely below the horizon. People there, had there been people, would have had no idea they existed. The same planet, completely different skies. Now here's where the story stops being beautiful and starts being terrifying. Rings don't just look dramatic. They act dramatically on the planet beneath them. A wide ring system circling Earth would have cast enormous shadows across the surface, particularly in equatorial regions where the ring sat directly overhead. Less sunlight reaching the surface means one thing: cooling. Scientists now believe that Earth's ring system may have played a direct role in triggering one of the most severe climate events in the planet's history, the Late Ordovician Ice Age. 466 million years ago, global temperatures plummeted. Ice sheets expanded from the poles. Sea levels dropped dramatically. And life, particularly marine life, which at that time was essentially all life, was devastated. The Late Ordovician mass extinction wiped out approximately 85% of all marine species on Earth. Let that number settle for a moment. 85%. The trilobites that had dominated Earth's oceans for hundreds of millions of years, gone. Entire families of marine life that had never been threatened, erased. It is the second largest mass extinction event in Earth's history. And for over a century, scientists struggled to fully explain what caused it. The rings hypothesis doesn't claim to be the only answer, but it may be a piece of the puzzle that was missing, hiding in plain sight, written in the pattern of craters along the equator. Nothing in the solar system lasts forever. Earth's rings, researchers estimate, persisted for up to 40 million years. Geologically speaking, that's a long time. Long enough to reshape climate, long enough to drive extinctions. But eventually, the forces working against the rings won. Earth's own gravity continuously pulled debris inward. The thin upper atmosphere created just enough drag on the lowest orbiting particles to slow them and drag them down. The moon's gravitational influence distorted orbital paths, sending material spiraling out of stable trajectories. And solar radiation pressure, the physical push of photons from the sun, gradually nudged smaller particles out of orbit entirely. The end result? A slow, spectacular rain. As the rings degraded, debris fell back to Earth as meteor showers, and in some cases, direct impacts. The craters geologists found near the equator, those are the scars of that final act. The last remnants of a ring system signing off. The sky cleared, the rings were gone, and Earth looked exactly as it does today. Here's a question worth sitting with. If Earth had rings today, what would actually change? The answer is almost everything. Start with space travel. Every launch vehicle that leaves Earth's surface would have to navigate through a debris field of rock and dust in low orbit. The James Webb Space Telescope, almost certainly destroyed before it reached its destination. The International Space Station, a collision risk every single day. Satellites, the infrastructure that runs GPS, weather forecasting, global communications, financial transactions, would be operating inside a shooting gallery. The Kessler syndrome, a cascade of collisions that makes an orbital zone permanently unusable, would be an ever-present threat instead of a distant warning. GPS accuracy would degrade. Radio interference from charged particles in the ring debris would disrupt signals continuously. And astronomy? Looking outward from a ringed planet is like trying to study the universe through a dirty window. Ancient civilizations built their entire calendars and mythologies around the night sky. Rings would have permanently obscured large portions of it. Then there's the climate. The shadows cast by rings would create permanent temperature variations, equatorial regions cooler than expected, disrupting monsoons, altering rainfall, shifting which regions of Earth are habitable. Civilization as we know it, built around predictable seasons, reliable agriculture, stable coastlines, would look fundamentally different. We benefit every single day from living on a ringless planet, and most of us have never once considered it. Here's the final piece of this story, and it's the one that tends to stay with people. Earth having rings once wasn't a freak accident. It was a natural consequence of orbital mechanics, cosmic debris, and the Roche Limit, forces that haven't gone away. The moon, our closest companion, is slowly drifting away from Earth, a few centimeters per year. Billions of years from now, when the sun expands into a red giant, the moon's orbital dynamics will change dramatically. And there are scenarios, not certain, but physically plausible, in which the moon itself eventually crosses a gravitational threshold, in which pieces of it, or debris from new asteroid encounters, once again form a ring around this planet. Earth's rings weren't a one-time event. They were chapter one. The universe doesn't promise stability. It promises change. What we call normal, this clean blue sphere hanging in space, is just the current frame of a much longer story. 466 million years ago, something looked up from the ocean and saw rings across the sky. And 466 million years from now, something might look up and see them again. If this video made you look at the sky even slightly differently, then it did exactly what it was supposed to do. Drop a comment below. If Earth had rings today, what do you think the biggest impact on human civilization would be? I read every single one, and some of the most interesting discussions on this channel start right there. If you're new here, this channel goes deep on the science hiding inside history, geology, and the cosmos. Hit subscribe and turn on notifications so you don't miss what's coming next. And if you want to keep going right now, the next video is right there. It covers another piece of Earth's hidden past that most people have never heard of. See you in the next one.